Hi everybody, I'm so sorry, I'm still not feeling well. So I'm not going to be there today, but I'm going to try and get through the notes with you. Hopefully yesterday's lesson wasn't too hard. It was a lot of stuff that you already know how to do from Algebra 2. Today's going to be a little bit more things you don't know yet, so hopefully this works out for you. Okay, so here we go. A regression line is a line that models how a response... It's my front door. My termite guy is here, but I'm not going to answer. The response variable y changes as an explanatory variable changes. And we learned that yesterday, what the difference was between response and explanatory. So here's the form that we're going to use, and this is going to be a little different than what you're used to. You're used to just y equals mx plus b, and in stats we do something a little different. So we have y hat, so it's so cute, equals a plus bx. Okay, and then let me show you what each of these things mean. So we call it y hat because it's not y. Y is the actual data that's explained by the x, and y hat is the predicted value. Because our line isn't going to be exact. It's going to try to help us predict the value. So y hat is the predicted value for a given x. Okay. And then b is the slope, of course. And the slope is going to have an interpretation that we're going to see, because you're not just going to find the slope. They're going to say, what does the slope mean in context? And so the slope is the amount. It's the amount that y is predicted. We're going to use that word a lot in this chapter. The amount that y is predicted to change when x increases by 1 unit. Okay, so that's slope. And you guys know slope by 1 unit. Okay, and then A is just the y-intercept. I know it's written a little bit differently, and this is when you go to stat calc. It's number 8 instead of number 4. We're going to use that one now. And this is the predicted value. There's that word again. The predicted value of y when x equals 0. Predicted value of y when x equals 0. Okay, awesome. Now we're going to talk about what a residual is, because the thing is we know how to find this line, a best fit. Our calculator does it, but what does the calculator do? Like how do you find this best line? And it's used, it's found by doing residuals. And so a residual is the difference between the actual value of y and the value of y predicted by the regression line. Regression line, which is y hat equals a plus bx. Okay, and then we call it the least squares regression line. So LSRL, okay, that's what that is. Sometimes you'll see that. Find LSRL. So the least squares regression line is the line that makes the sum of the squared residuals as small as possible. Okay, so let's look at this graph right here. So it's a scatter plot. All these red dots here are all just scatter plot, and it's talking about the miles driven and the price of a car. So the more miles that the car gets driven, the less the value of the car is, or the value of the car is going down, basically. So if you have, 100,000 miles on your car, then your car is only worth a certain amount. And if you have more than that, then it keeps decreasing as you go along. Well, this is right here, from here to here, these are all called residuals. And they are all the distance, basically, between the actual dot and the predicted dot on the line. And so if we were to take the sum of the residuals here, see how this would be positive, this would be positive, this would be negative, negative, negative. Yeah, so all the stuff underneath is going to be negative. And so when you add up the residuals, it equals 0. Well, that doesn't really help us much. And so what they do is they take the sum of the squared residuals. So they take all these residuals and they square. I know they actually even drew squares here, but they square that number. And they do that so that you can make it positive. And so when you add them all up, it's going to be a huge number. Okay, because you're squaring these numbers and adding them all up. And so that's how they find the best line, the line of best fit, the least square. That's what it's called. The least squares regression line, because it's the least amount that you've added up once you've squared all the residuals. Okay, so here we go. Here's the data from one of the groups, and the group forgot to record their measurements for 5 rubber bands. So we're going to make a scatter plot on our calculator, and we're going to calculate the least squares regression line. Okay, so go to your calculator and put in L1 and L2, and then leave off this point right here because we don't have it. And so you'll type in 0, 1, 2, 3, 4, 6, 7, and then 25, 32, so on to 78. And then we did scatter plot yesterday, so let's just calculate the least squares regression line. So I'll give you a second if you want to pause, put those in. I want you to practice this. I know I went through stuff really fast yesterday. I just wasn't feeling good, so I wanted to get through it. So make a scatter plot on your calculator. If I ask you to do that, usually I ask you to, sketch a graph of it, and that's fine. We could do that, but and then calculate the least squares regression line. So once you do that, go back to stat, over to calc number 8. Okay, and so what we get is, let me erase this and I need this room. We get y hat equals 25.333, and we'll talk about decimal places in just a minute, plus 7.464x. Okay, now what I did was I just introduced 2 variables. And so to my grader, to me, when you're taking a test or quiz, you have to tell me what each of these variables stand for. So y hat is the predicted, always use that word, always. It's the predicted distance traveled. Okay, it's not the exact distance traveled. Like, for example, if we were to use this equation and put in 1, we're not going to get 32. So it's the predicted, it's close, it's going to be close. Predicted distance traveled, and x equals the number of rubber bands. Okay, the other way that the book will do this, rubber bands, is instead of writing y and x, they actually write the words like this. This is what they'll do. I'm going to put a big or right here. They'll write distance with a hat over it. So that's the predicted distance equals 25.333 plus 7.464 times rubber bands. Okay, and some people might like to do it that way. I always like to write an equation with y hat and x and show you what y hat and x are. But people like to use this because you can see exactly what the units are if you needed to plug something in. Okay, when displaying the equation of the least squares regression line, the calculator will report the slope and intercept with much more precision than we need. There's no firm rule about how many decimal places to show. Our advice, decide how much to round based on the context of the problem. Okay, so I rounded to 3. I could have rounded to 2 decimal places here. I was just trying to be super accurate. Back to the other page, 5 is in the range of our x values. See how our x's go from 0 to 7? And so 5 would be a good number to plug in if we didn't have it. 20 is way down the road, and so things might change when you get all the way out to 20. This might not stay the same. Excuse me. Sorry, guys. All right. Use the regression line to predict the distance Barbie travels for 5 rubber bands and show your work. Okay, so we're going to do y hat equals. Make sure you show your work. It's really important, unless it's a multiple choice question. And then we're going to plug in 5 for x. And you do that in your calculator, and you should get 62.653 centimeters. Okay, And one of the group members later found the measurement for 5 rubber bands, and it was 64. So was the prediction from number 2 too high or too low? Okay, so here's how you find a residual. That's what they're asking for on this problem. They're asking for the residual at x equals 5. So the residual is found by doing y minus y hat. And that's something that you have to memorize. I like to memorize it as AP, like that's what we're taking, AP stats. And A stands for actual. And I'm sure you know what P stands for, predicted. So that's always helped me remember which order it is. So it's AP, actual minus predicted. So the actual was 64 minus the predicted, which was 62.653. And so we get 1.347 centimeters. Don't forget units. And so when we look at these numbers, the actual was 64, the predicted was 62. We would say that the predicted was 1.347 centimeters too low. Okay, and that's just looking at the numbers, 64 and 62. 62 is definitely less than 64. And so the predicted was a little bit too low than what it was the actual. Now, predict the distance that Barbie would travel if the group used 20 rubber bands. Okay, so we'll plug in 20, 25.333 plus 7.464 times 20. And then when you do that on your calculator, you should get 174.613 centimeters. Okay, now this follow-up question says, would you trust this prediction more or less than the one you made in B? So B, we made a prediction with 5 rubber bands, and this we made a prediction with 20 rubber bands. And if we go back, and so for me, I would say that, would you trust the prediction more or less than the prediction? I would trust it less because it's so far away from the other points. Because it's so far away from the other points. Okay, and that is going to bring us to the idea of extrapolation. So extrapolation is the use of a regression line for prediction outside the interval of x values used to obtain the line. The further we extrapolate, so the further we go out away from our, x's that were given to us, the less reliable the prediction. So if I asked you, instead of 20, how about 40 rubber bands or 100? Okay, so the further we get away from our data points, which stopped at 7, the less reliable the prediction would be. Okay, so what is the y-intercept of the equation of the regression line? So if you look up here, I can find it right here. Our y-intercept is 25.33 centimeters. It's always the y value. Okay, and what does it mean? What does it mean to be a y-intercept? Well, here's what it means. When 0 rubber bands are used, the predicted distance traveled, there's that word again, is about 25.3 centimeters. Okay, and I have some interpretations down here. I hate memorizing stuff, but sometimes you just have to, unless you know what the y-intercept means. I mean, if you think about it as a graph, the y-intercept is a dot on the y-axis, and it's always when x equals 0. So if you know that 0 rubber bands here, okay, 0 rubber bands are used, the predicted distance is going to be the y-intercept. I mean, that should make sense. It's right here, it's 25, and then your line's going up from there. All right, now what is the slope of the regression line? And what does it mean? Oops, I'm writing in a highlighter again. Okay, I don't like explain everything. All right, slope 7.464, and slope is a rate of change, so it's centimeters per rubber bands. Okay, and you should know slope. Slope's just the change in y over the change in x. For you calculus people, it's delta y over delta x, right? So it's always the y variable over the x variable as your rate of change. And so here's what we would say. What does it mean? Well, it means that with each additional rubber band, so if we add one rubber band, okay, the predicted distance traveled, let me get rid of this guy over here. Oh no. I don't think I can. No, he won't erase. Okay. All right. The predicted distance traveled increases. So slope's positive here because that word's going to change. It could be decreases, okay, if it's negative slope. But with each additional x value, 1x added, the predicted distance traveled increases by whatever the slope is, 7.464 centimeters. Okay. Now, when asked to interpret the slope or y-intercept, it's very important to include the word predicted. So I've been saying that a lot. Otherwise, it might appear that you believe the regression equation provides actual values of y. So actual values of y are the y's that you do when you do the experiment. Okay, when I did rubber bands, 5 rubber bands, I got 64. And then the predicted is always the y hat. And so I've labeled some interpretations down here. So with each additional x context, so rubber bands, the predicted distance traveled increases or decreases by whatever the slope is, okay? So hopefully you know slope, you know y-intercept enough that you don't have to memorize this stuff, but they're here for you. And then the residual, if you had to interpret the residual, it would be the actual y context was a minus p. That's where you actually find the residual, a minus p, higher or lower than predicted, and then you have to say at what x value you're talking about. Up here we were talking about the predicted at 5 rubber bands, okay? Yeah, so you have to make sure that you say that if you're going to interpret residual. Okay, we're going to go through this one example right here, and we're going to stop at residual plots. We'll go ahead and make this 3-2b. We'll do that on Monday. And I'm coming back Monday. I don't care how sick I am. I'm coming back. This is ridiculous. All right, some data were collected on the weight of a male white laboratory rat for the first 25 weeks after its birth. A scatter plot of y equals weight in grams and x equals time since birth in weeks shows a fairly strong positive linear relationship. The regression equation y hat equals 100 plus 40x models the data fairly well. Interpret the slope of the regression line. Okay, you can pause it, try to think about it yourself. So the slope right here is 40. And so let's go ahead and think about what the response value and everything is. So y hat is the predicted weight. The predicted weight in grams, it looks like. And x is going to be the number of weeks. Okay, so here we go. Interpret the slope. So with each additional week, the predicted weight of the rat, okay, there's that word again. You're going to use it all the time. Predicted weight of the rat, it's positive 40, so it increases by 40 grams. So the rat's getting bigger and bigger, and this is for the first 25 weeks after its birth. Sorry. Now, does the value of the y-intercept have meaning in this context? Sometimes it doesn't. Sometimes the y-intercept has no meaning in the context, but let's go ahead and take a look. The y-intercept is equal to 100 grams, and that would make sense because we would say when a rat is 0 weeks old, you could say at birth, but it's nice just to keep it the same every time. So when the rat is 0 weeks old, so when the X context is 0, the predicted weight is 100 grams. Predicted weight is 100 grams. And those templates are really good until you start to kind of see it, and then it just kind of come naturally, hopefully. Okay, predict the rat's weight at 16 weeks old. Make sure you show work here. And we're going to plug this in, and we get 100 plus 40 times 16. Okay, and so we get 740 grams. Okay, calculate and interpret the residual of the rat if the rat weighed 700 grams at 16 weeks old. Okay, so let's first calculate the residual, and it's going to be actual minus predicted. So the actual weight was 700 minus 740, which would be negative 40 grams. Okay, so here's the interpretation. Here's what they want. You would say the actual weight is 40 grams less than the predicted weight. And here's, I think, what I left off on that last time when I was interpreting residual. But you're supposed to say at X equals 16 weeks. Okay, because the residual is going to be different for every different week that you have. So the residual here is negative 40, but it's negative 40 only at X equals 16. It's not at X equals 12 or 14 or whatever. Okay, so the actual weight is 40 grams. So actual is 700. This was 740. So the actual weight is 40 grams less than the predicted weight. You could also say the predicted weight was 40 grams more. Okay, whichever one you want to use. It doesn't matter. Now, should you use this line to predict the rat's weight at 2 years old? 2 years old. Use the equation to make a prediction. Discuss your confidence in the result. Well, first of all, you should say no, because this was only for the first 25 weeks after birth. Okay. So you'd say no. The model is for the first 25 weeks. Now, they want us to now use the equation to make the prediction. All right, so y hat equals 100 plus 40, and then 2 years old, that would be 52 times 2, 52 weeks in a year times 2 would be 104. And so you get that this rat would weigh 4,260 grams. Now it says there are 454 grams in a pound, so we could actually go 1 pound over 454 grams. And so that would be that the rat would weigh 9.4 pounds. That's a disgusting rat. That's like bigger than some of your dogs, I think, if you have a little tiny yip dog. Okay, so, and discuss your confidence in this result. Okay, so we would say that the data, the data was for the first 25 weeks. We already said that. So X equals 104 is way outside. And just say X equals 104 is way outside the range. Way outside the range, and 9.4 pounds would be way too much. Way too high. Because there's got to be a point where the rat kind of levels off in its weight. There's no way it's just going to keep getting bigger and bigger till it dies. And then we could actually say that this is extrapolation. Yeah, so you might want to know that word, extrapolation. Okay, that's it. We're going to pick up residual plots because this I want to teach you on your calculator, and I just don't have the capabilities right now. So we might switch up some things next week, move some things around, but hopefully we're still on track. I hope you guys are doing okay. I missed you. Have a great weekend. Say hi to your sub for me. Bye.